Hello and welcome everyone to PyData Boston's October Meetup. For those of you who don't know, PyData is an educational program of a nonprofit organization called NumFOCUS. The global PyData network promotes discussion of best practices, new approaches, and emerging technologies for data management, processing, analytics, and visualization. We are a community of users and developers of open to share ideas and learn from each other. We also approach data science using many languages, including but not limited to Python, Julia, and R. My name is Anita Yip, and I'm one of the co-organizers of PyData Boston. I'm really excited to have Mike Woodward here with us today to talk about forecasting US presidential elections. And before we get to his talk, I want to talk about a few items. First, feel free to introduce yourselves in the chat and in Slack. There's also an introduction channel on Slack. And as we continue to hold these virtual events, we want to continue to build our community. And of course, if you have questions during the presentation, please unmute yourself and chime in for a real-time conversation. For those of you who aren't speaking, please make sure to turn off your microphones. You can find us at our website, pydataboston.github.io, and on social media. Feel free to tweet about today's talk using hashtag PyDataBoss. If you haven't joined our Slack community yet, please do so. And this information is all on our Meetup page as well. Now I'll announce some upcoming events. First, PyData Global is happening from November 11th to the 15th. This premier global data science conference will be held online for the first time. And it's 5 days packed with talks, tutorials, posters, open source sprints, and a digital hallway track. So check out the website at global.pydata.org for more info. Next, PyData Boston is holding a set of talks on Wednesday, November 18th from 7 to 9 p.m. First, we'll hear from Angela Vujic on brain-computer interfaces, and she'll be presenting a tutorial on how to interface with the OpenBCI using Python and useful Python libraries for electrophysiology. Afterwards, Austin Eovito and Upkar Lidar will deliver a talk on explainable workflows using Python, focusing on skills and tactics used to help data scientists articulate their findings to end users, stakeholders, and other scientists. We hope you'll be able to join us then as well. As with all meetings, we want to reiterate that PyData is dedicated to providing a harassment-free experience for everyone. Please behave professionally, as we do not tolerate harassment in any form. You can view the longer version of our code of conduct at this website. Feel free to reach out to any of the organizers if you have any concerns. And thank you for helping making this a welcoming community for all of us. Lastly, these meetings are only made possible with the help of volunteers. And you can do anything from organizing an event by recruiting speakers to creating partnerships. When we're back to meeting in person, you might also help secure venues and food. What's more, you can volunteer to present and speak at one of our meetings. You don't have to have a full talk ready when you fill out the speaker form, as the organizing team can help you through it. Currently, we have one opening in December for a medium-length talk, and would be especially interested in a talk on machine learning model or how you might be leveraging machine learning models. And as always, we have an ongoing need for speakers in January and beyond. Mike actually was someone who filled out the Google form on our Meetup page expressing interest in speaking. So I reached out back in June. Mike finished the bulk of his talk in August, and then we made this event happen. So I'm really excited to hear more from Mike about this timely topic. And with that, I'll turn it over to Mike to start presenting.
Okay, thank you. I'll just share my screen. Just bear with me a second. Oh, sorry. Can you see my screen? Can you guys see where it says forecasting US presidential elections?
Yes.
Excellent, wonderful, thank you. So for those of you who have maybe mistakenly tuned in and think you're going to see a presentation about people gyrating around polls, beautiful people doing it, you're not going to see that. You're going to be very disappointed. But for those of you who have tuned in expecting a presentation about US presidential elections, hopefully you'll be less disappointed by what you're about to hear. Okay, let's talk a little bit about what I'm going to talk about over the next few minutes, next 45 minutes or so. I'm going to talk about what went wrong in 2016. But I'm also going to use my experiences as an opinion poll street interviewer to give some insight into what went wrong. And I'm going to talk about what it's really like to be an opinion pollster on the street in my case. I'm then going to change tact and have a look at election modeling. And this is where we're going to get into some more statistics and modeling of data and what's going on. And also, I'm going to let you into some secrets about why some forecasters have got things badly wrong. I'll explain where and their models they got it wrong, and then what we can do to get it right. That's going to be more mathematical. Very briefly, I'm going to touch on data sources. If this is the kind of thing that you want to do yourself, I'm going to point you where you can get the data. I'm going to show you the model that I've got working. Now, for those of you who are Python programmers or working in a Python environment and who are interested in business intelligence apps using Python, what I'm going to show you is, in effect, a business application written using Python, 100% Python, no other language. And I'll show you this. I'll give you a demonstration of how it works so you get a sense of what's actually possible. Then I'm going to explain how the model was put together and some of the architecture and some of the techniques I've used to build the model quickly. And hopefully those will be of interest to you for those of you who are Python programmers and looking at BI apps and that kind of stuff. Finally, we'll wrap up and I'll talk about some lessons learned and some other places where we can apply this technology that I'm going to talk about. So if you want to dive deeper into this session is being recorded. I'll make the slides available if you care about the slides. I've also maintained a blog, which is mostly about management and statistics. But what I've done in my blog over the last couple of weeks is I blogged about a lot of the topics that I'm talking about tonight, and I provide more details, including academic references, references to papers, that kind of stuff as well. So today on my blog, I posted a summary blog, which is kind of a greatest hits of all the election stuff I've posted. So you can find all the election stuff that I've done in one convenient place. And the source code to the project that I'm going to show you that actually shows the the presidential election and the forecasting and the charts and all the rest of it, that's all available on GitLab, or rather on GitHub. If you could just follow the links there. In the chat, I've put links through to the GitHub site and to my blog as well, and a couple of other bits and pieces if you're interested. All right, so let me give you a little bit about my background. A long time ago, and I won't tell you how long ago, but quite a long time ago, I worked for a market research company in the UK. It was a well-known market research company, an opinion polling company. It's active in the United States. I think it's a US company. And I was a street interviewer, right? Now, in the opinion poll hierarchy, that's basically the lowest life form, right? The lowest bottom of the rung of the opinion poll hierarchy. So I was sent out on the streets with a clipboard to go and ask people questions. And that's where I learned, the big lesson that I learned is that random sampling does not exist, right? Despite what the textbooks tell you, that it just doesn't exist at all. Let me give you an example, a very quick example. I was doing a political opinion poll and I needed a male in the age range 20 to 25, and I'll talk about quotas in a minute. And I saw two men coming towards me on the street. Now, one was a typical college student looking person, and the other one was a skinhead in full skinhead clothing. Right now, if you imagine, I'm a bit weedy, frankly, right? And imagine standing on a street corner with a clipboard and you've got one of these two men to interview. Which one would you approach? Now, obviously, survival instincts in kind of frankly, what was a bit of a tougher area of London, I made my decision. But that's introducing bias. So every day when you're out in the streets interviewing people, there is bias about who you interview and who do you not. So there's bias about times when you interview people. So the people out in the streets at 7 o'clock are different from the people at midday, are different from the people at 5 o'clock. Or in turn, different from the people at 11 o'clock at night. Also, where do you interview them? If you interview people outside of the library, you'll get one set of answers. Outside a school, you'll get a different set of answers. And maybe outside the factory gates, a different set of answers. Now, to counter that kind of selection bias, which is conscious or unconscious, opinion poll companies give their interviewers quotas. And these are typically demographic breakdowns of the population of the area that you're interviewing in. So for example, in a constituency, in a parliamentary constituency in the UK, you might have a breakdown from the Census Bureau, and it would be, well, for this kind of sample size, you'd expect so many males of this age ranges, different age ranges, so many females of this age range, maybe some income levels, maybe some ethnicity pieces, whatever. There'll be various criteria that you'll select between. Sometimes, depending on the poll, there will be other criteria as well that are important. But, and this is going to come back when we talk about what happened in 2016, but each question that you ask costs time and money. Each question that you ask about qualifying the responses, right? Each of those questions could meet with a refusal, and every additional question that you ask is likely to upset some more people. So for example, if I ask you, who are you going to vote for? You might well tell me, but then if I say, well, can you tell me your age range? Can you tell me where you live? Can you tell me your income level? Right, and the list goes on, and eventually you're going to get very fed up and you'll find my questions intrusive. So opinion pollsters know this, and they try to restrict the number of questions to just the ones that are relevant, right, to get a representative sample. Note that I didn't say a random sample. Now, nowadays, people have gone from being from street interviewing to basically the phone and the internet because they're cheaper. But the problems are still there. They've just become a little bit more subtle, if you like, but they're still there. But the point I want to leave you with before we get on to talking about 2016 is that random sampling for opinion polls does not exist, all right? And that each opinion poll company has their own methodology for sampling, and that introduces bias. Now, they try and make the bias as small as possible. They're continually tweaking their algorithms, but each opinion poll company has their own set of biases. And that's going to come into, that will be very important later on when we start looking at error models. All right, by the way, if you want to ask questions, you can always unmute yourself and ask, and I'm happy to take questions as we go along. All right, so let's talk about 2016 and what happened. And bottom line, sampling was the problem in 2016. So where it went right was obviously forecasting the national vote, but that's not how US elections are decided. Where it went wrong was at the state level. Right. Now, subsequent to the 2016 election, the American Association for Public Opinion Research and Pew Research did a study to try and find out what went wrong. Now, the obvious point is what went wrong so you don't do it again. So there's a couple of things that they looked at. And one thing I do want to talk about is this concept of the shy Trump voter. What they said is that there was this concept that Trump voters were somehow shy and retiring and wouldn't admit to pollsters that they actually intended to vote for Trump. Now, Pew Research, when they did their research, said that they found no evidence for this whatsoever. And I've heard of this idea in the UK, this a shy Tory voter concept, utter nonsense, right? And as it turns out, there's very limited support for it. It tends to be something that the losers like, because it gives them a sense of feeling superior, right? Because if you voted for the losing party, for the winning party, there must be something wrong with you. Well, not really, no. And it's not really an effect. So you may have heard about the idea of shy Trump voters. In reality, it's just not a factor at all. Two factors were important in 2016. So one was education. In previous elections, the effective election, or rather educational level on people's voting behavior was minimal. But in 2016, it was not. And in 2016, it showed a very distinct bias, right? Now, what happened is, in the opinion polls that took place in 2016, they did not include education as a factor to basically give representative samples. And they didn't do it because they tried to minimize the number of questions that they asked, the qualifying questions. So that's the reason why they didn't include it. That turned out to be a very important factor in 2016. And what I've heard for 2020 is that education is being included. The other thing that was very different in 2016 is there appeared to be a late change in voter preferences. So you can see that in the national vote data as well, very clearly a swing towards Trump in the national vote data. But at the state level, the opinion polling stopped before the election. So voter changes that took place in the last week or even the last few days weren't captured at the state level polls, right? And that's why those polls got it wrong. And if you look at the data about, how many polls got it wrong and for how many states, it's between 5 and 7 states in 2016, depending on exactly how you count it. Right, but this concept of the polls getting it wrong before isn't new. So in the UK general elections, there's been a couple of them where the opinion pollsters have got it very badly wrong. And the causes there have been sampling again, right? They didn't do proper random sampling. Turnout models as well. So it turns out that the left wing and the right wing turn out to vote at different rates, right? The right wing tend to be very enthusiastic and get out of bed and vote, and the left wing tend to stay in bed or watch TV or whatever it is they do, but don't vote. UK also had a problem with herding, which is where opinion polls, so let's imagine it's a phenomenon that's been seen in the US, but less so. So let's imagine that you have 10 opinion polls and they all say that candidate A has got 55% of the vote, and you're working for an opinion poll company and your poll suggests that instead candidate A is 45%. Now that makes your poll an outlier, makes you stick out, and you might well be correct. But the UK pollsters, what happened is that some of the results were suppressed, some of the outlying results were suppressed, and they changed some of their methodologies to fall more in line with the other pollsters, which meant collectively they moved as a herd, and unfortunately they moved in the wrong direction. And you can read the reports about this and about why exactly they got it wrong. In the US, there's also a history of election failures as well, polling election failures, some spectacular ones. One thing I do recommend, everybody who's involved in data science, I recommend that you look at the story of what happened at the Literary Digest. Okay, that was a fantastically large poll, one of the largest opinion polls I've ever heard of, orders of magnitude bigger than anything that I've seen done recently, but it got it hopelessly wrong. And what that proves is that size isn't everything, okay? If your sampling methodology isn't right, no matter what the size of your data set is, you're going to get the wrong answer. Okay.
Going back to the Pew research and AAPOR, Smith had a question about how did they find out that education was a big factor if the data wasn't collected in the first place?
Oh, one of the things that you can do is go back, right? In some cases, data was collected at the time. In other cases, you can go back and re-interview voters. So, for example, a lot of surveys actually ask for the names and addresses of respondents. And that's one thing that I had to do, right, as an opinion pollster, partly because they wanted to prove that I'd actually talked to these people so I could get my money. So in most cases, or in a lot of cases, they do have names, addresses of people, and you can do subsequent callbacks after the election to figure out what happened. Now, this is not everybody, and not everybody gives you an address, but if you can get enough, you can attempt some correlation. The other piece is that in every election, every opinion poll organization uses slightly different sampling techniques, and occasionally they will use education or other factors as well. And you can just about glean enough data to look at it. So it's not an exact science. There is a big margin of error on this, but you can actually do that. Most opinion pollsters do actually have the names and addresses of people and the phone numbers of people that they spoke to, so they can attempt a callback. Of course, how many people choose to talk to them later, the non-response issue is a problem, but at least they do have that data set. Did I answer that question? Okay, I'm going to assume that I did. Okay.
Smith said yes.
Okay, thank you. All right, so let's talk about opinion poll models. So this is where we get to the statistics part of the evening. So let's talk about what does not work, right? Every 4 years, we have a spate of these models that don't work. I'll give you an example, right? A lot of them are based on fundamentals or heuristics or whatever. In 2012, there was a great example. 2 political science professors at Colorado University at Boulder produced a study, and they looked at, I think it was GDP and inflation and unemployment and a whole bunch of other factors, and they forecast basically a Romney landslide. Okay, they were very confident about their model because they'd looked back and they selected all these factors, and they'd looked back 50 years or a long time anyway, and they'd seen that every election these factors had pointed in a particular direction, and in 2012 they felt it would point in the same direction, but sadly for them it did not. So these type of heuristic-based or fundamental-based models have an absolutely diabolical track record, right? They're absolutely useless at forecasting. There's a book here. If you want to read a book about useless ways of forecasting, this book that's on the screen by Ray Fair is a great read. He talks about how these models are developed, and he starts from a relatively simple model, and then it gets it wrong, and they add in another factor, and it gets it right, and then it gets it wrong, then they add in another factor. So gradually over time, you can see that these models get bigger and bigger and bigger as they're adding in more factors, right, to account for the variability in the data that they're seeing. One of the factors that they added in was a thing called electability, which is a numeric number that they somehow decide that one candidate is more electable than another. And unfortunately, the way that this worked is that they allocated the number after the election result was known. So again, not very helpful. So for those of you who've done a lot of mathematical modeling, you know that this approach just isn't good, right? It's just not sound scientifically, and that's been known for a very, very long time. It falls, the post hoc fallacy is just huge here. There's spurious correlations all over the place. And in England, we call things where you choose a number a fudge factor, and there's loads and loads of fudge factors in these models as well. So it's just really not very deterministic, really not very sound as a modeling approach. Technically, it's just abysmal. To Ray Fair's credit, though, he does say in his book that there's absolutely no evidence that voters, when they go to the polling booths, actually bear any of these factors in mind. So what you have is a case where you're building a model based on fundamentals where there's no evidence at all that voters actually care about the things that are in your model. It's not a good place to be modeling. Now, I would have said that these are no good as priors. However, I do believe, based on what I've seen recently, that Nate Silver is using some of these factors as priors as well and factoring into his calculations. He's the only one who's seen his model, or rather the people at his company, so I can't tell you for sure, but reading his blog posts, I believe that somehow he factors in some of these concepts like GDP and inflation and unemployment and other things. But this concept about, the post hoc fallacy and taking a bunch of factors and then using them, see how they were correlated and then making a forecast, it's a zombie idea that will not die. And every 4 years, these ideas pop up again and again. Really, they're worth nothing. So if these things are worth nothing, what is and what does work? Well, poll aggregation, all right? So the idea is that polling captures all of the factors that people care about when they go to vote. So you're not asking them, do they think about GDP or inflation or whatever else it is? You're asking them, how do you intend to vote in a week's time, a month's time, whatever it is? For the modeling work that I'm going to show you, it focuses on state polls, right? And what we do, not all states have polls in places which are very strongly Republican or very strongly Democratic. They don't tend to be polls. I mean, why would you bother running opinion polls in Wyoming when you know it's a very Republican state? The same thing for Alaska and the same thing for Hawaii and Washington, D.C. as well. There really isn't much point running an opinion poll, for example, in Washington, D.C. because it's just ridiculously Democratic, right? And the same thing for Wyoming and the Republican states as well. In those cases, as a prior, we use the prior election results. So who's doing this modeling? Well, obviously Nate Silver here, who is the king of forecasters. His model, the reason why he did better in 2016 than the others is he had a more sophisticated error handling. And I'm going to talk about that in a second. Error handling is what took down a lot of models in 2016, including the model that I had at the time. Sam Wang, who is a professor of neuroscience at Princeton, whose kind of hobby is analyzing elections, he produced a model, and his model included, well, it didn't include proper error handling, as I'll talk about in a second. However, I've got to say that my model originally started off by taking his model, which he very generously gives the source code for, but it's diverged a lot since then. But the general approach that I'm taking is largely due to Sam Wang. But the way that he models his errors gives a way, way over certain result. And I'm going to talk about error handling a lot more in the next slide or so. So the track record of these forecasts is good, sort of. In 2008, these models correctly predicted every state, all of the states in the Union. In 2012, every state was correctly forecast. And in 2016, well, it didn't work out so good, right? And largely it didn't work out so good because the state level polls were off for reasons I've already discussed. So let's talk about more about the more about the process of doing this. So this is how these poll aggregation models tend to work. So you start off with your previous election results as your prior, and in some cases they will be your forecast for states without state level opinion polls. You'll take your state level opinion polls and do cleanup. There is a ton of cleanup to be done. So if you want to play around with this data, even if you get it from Nate Silver or some of the other aggregators, you're going to still have to do a ton of cleanup yourself, right? And in fact, for the model I'm going to show you, the code I'm going to show you, I've had to do a lot of manual cleanup of the data. There's just no way of automating it. So you go through, you load those models. The idea is that you take those state models and you produce an aggregate poll model. From the aggregate poll model, you can work out a probability of victory for each candidate. So for Trump and Biden, you can work out a probability of them winning that state. Right. What's important here is the error model, and on the next slide, we'll get into error models in more detail. But the error model really impacts the probability of victory, okay? And I'll say more about that later. But once you've got a probability of victory for both candidates for every single state, you can combine them and produce an electoral college model. The electoral college model, there's 538 electoral college votes up for grabs. Not every combination is possible. And you can win between 0 and 538 electoral college votes. The last thing we do here is actually display the data in a way that's consumable by users to make a forecast of where the electoral college stands right now, according to the model. And then you can have a look on a state-by-state basis and some other bits and pieces, as we'll see. An incorrect error model will lead to great overconfidence. And another point I have to make here is that Maine and Nebraska use a slightly different election method from the other states. All of the other states use winner-take-all. Maine and Nebraska use a congressional district model. So in a more sophisticated version of my model, I take that into account, but I don't in this more basic version. All right, error models and state-level modeling. So for those of you who remember your statistics and normal distributions, this top equation is really what's governing the probability of victory for a candidate. So D is the spread between candidates. So for example, in a state like Massachusetts, Biden is ahead of Trump by about 20% plus. That gives us a D of about 0.2, right? So if we're going to work out for a state like Massachusetts what the probability of Biden winning it is, we can take D as being 0.2. We can work out the standard deviation for the polls, and I'll talk about that a little bit later. And from that, we can work out a probability of Biden winning Massachusetts or Trump winning Wyoming or whatever else it is. This is a standard equation derived very simply from the normalization and probability theory, but there are huge problems with it. So the big problem is it gives you way over certain results. It assumes random sampling, which I've already told you doesn't exist. So it assumes random sampling, but once you get past a spread of 1 or 2%, this equation, the top equation, starts to give you probabilities of winning for the candidate of 90% plus. So very quickly, if you can maintain a small lead, it gives you a really high certainty of results. So a lot of books and courses give you variations of this equation or graphical representations of it. A lot of those books and courses are wrong. And to his credit, I'm going to give a call out to Raphael Irizarry. I'm sorry, I've probably mispronounced his name here, who has a great book, a free book that talks about election theory and election modeling, who gets it right. And he's doing a course on data science, and one of the courses actually includes a lot of stuff on election modeling, and he gets it right as well. And this equation that I've called out below actually comes from his course. So what he's saying here is, if you're working out the spread for a candidate, well, it's not actually the spread that you measure, right? There's the spread that you measure plus an election bias, plus a house bias, plus obviously a random error, right, that's going on. that these two things are missing from the House bias and the general election bias are missing from most analysis. They're missing from Sam Wang's analysis. But Nate Silver, I believe from what he's written, actually includes them. And you can attempt a analysis of the magnitude of these errors, right, from the opinion polling data. Right? It's a little bit difficult to do, but you can do it. So this gives you a much, much higher level of uncertainty than the random sample only. In fact, my suspicion is that if you probably took into account the systemic bias and other bits and pieces as well, you probably end up with a margin of error twice that of what the polls are counting, rather what the polls are saying. So the other problem or the other feature of this type of model is that the median, or rather the mean values of these errors or biases is not zero. So for random sampling, the mean bias is zero, but it is not for some of these other effects as well. And that couples into the error analysis in quite complicated ways. So a couple of other things that this first equation doesn't take into account, and I know that most election models don't take into account, is turnout effects. So I've already said that the left wing turn out less frequently than the right wing. That kind of modeling as well is just not in this equation at all. Don't knows and won't says isn't included here. So let me give you an example of two different elections. So one election, the candidate, it's 45% for one candidate, 55% for another, and the spread between them is 10% or 0.1 for D, so you can work out an election victory, right? They're probably very certain for the candidate of 55%. But imagine another election where one candidate is on 15% and the other candidate is on 5%, and the remaining 80% of the voters are undecided. There is a 10% spread there as well, which means that according to the first equation, right, the candidate in the lead has the same chance as winning in the 15-5 case as in the 55-45 case. Plainly, that's not right. So it doesn't take into account don't knows and won't says. Now, as a kind of point for this election, the number of don't knows is actually very low. It seems as if in the 2020 election, most people have made up their mind, frankly. Wasn't the case in 2016, but it is the case in 2020. The number of don't knows is historically low. So how do you combine opinion polls? This is where I diverge from the textbooks a lot and where the textbooks get it wrong as well. So the naive case for textbooks is to say, well, what we're going to do is if we're combining two opinion polls, we'll just take the mean of them. Or if we're combining 3 or 4 polls, we'll take the mean. That is wrong, right? If you start playing around with opinion polling data, you'll see it's almost the definition of a data set with large outliers. Outliers absolutely all over the place, right, for this model, or rather for this technology. So the mean isn't an appropriate way. Weighted median by size is probably a better choice. A lot of the books talk about the combination of errors and the uncertainty using an equation like the one here I've shown you. But the reality is, of course, that's assuming random sampling, which I've told you doesn't exist. And the biases for each opinion poll organization are different because they're all using their different methodologies. So you can't combine them in that kind of naive way. And again, as I've said, the biases don't have a mean value of 0 either. Right? So you have to be careful how they propagate. The reality, the problem with these results, and it was a problem with my model in 2016, is it gives way, way over certain results. If you follow the textbook methodology, textbook methodology causes you to shrink your uncertainty, shrink your margin of error, and it gives you this, a combination. Even if you use median, right, you end up with a way, way over certain result. So my choice for this election was to simplify things a lot in my latest iteration of my model. I took a 7-day window rather than the 10-day window that I took before. It's a rolling window. What I do for each state is take all of the opinion polls that occurred in that state in that rolling window, rank them by spread, right? So it can be in favor of the Democratic candidate or the Republican candidate, doesn't really matter. You choose one, you rank them by spread, and I choose the median poll, and I take the error for that poll. Now, I'm still not properly taking into account things like bias, for example, house bias or election bias. But for right now, that gives me a higher level of uncertainty than I had in my previous model. So it's not the most sophisticated way forward, but it works, and it gives me a shorter window, so I should be able to capture late breaking changes. Right, now how this works in terms of working out an electoral college model. So what I'm able to do for each state and for each candidate is work out a probability of victory. So for Biden, I can work out a probability of victory for every state, and for Trump, I can work out a probability of victory for each state. And using the generator polynomial, so I won't go back and explain what that is, that's back to your probability theory classes, I can work out a probability distribution covering all 538 electoral college votes, right? And what I end up with is a distribution for each candidate by day, right? So I can see how the race evolves, and I'll show you a demonstration of that a bit later. So using this technique, I can get basically my electoral college model, right? So some vulnerabilities for this, actually doing the data cleanup is pretty tough, right? This is not the easiest data set in the world to clean up. You're having to look at the polls and figure things out and figure out what's going on. There tends to be multiple iterations of opinion polls with slightly different factors, but you only want one, but which one do you include is difficult. I'm making the assumption that the closer that we get to the election, the more polls there are, which is mostly true. I said my error model doesn't include house bias, although I've tried to minimize my my minimization of errors. Don't knows and won't says aren't included. 2020, not really a problem, but I really have to do something about that for another election. And Maine and Nebraska, using the congressional district model, I don't have that in this model. I assume they're winner takes all. So for the polls as well, late changes in voter intent at the state level may well still mess things up, right? You're relying on your underlying data. There's nothing that you can do about that. If there are systemic biases across pollsters, as there were in 2016, it'll be very difficult to get that. Again, education is unlikely to be a problem in this election because they're all aware of it and correcting for it, but there could be some other factor that we don't know about that we find after the election was a factor. And it could also changes in the voter population as well. So this is largely related to turnout as well. I heard in 2016 that the African-American turnout was lower, the white rural turnout was higher, I've heard. I don't know if that's true, but it's possible that you got changes in voter populations and relative changes in turnout levels depending on the election. Very hard to model. So again, those are vulnerabilities of this approach. Right, now, for those of you who would like to do this yourself and you want to play around with the data, there are some data sources here to get your data. Originally, I got my data in 2016 from the Pollster API, but that's bitten the dust, sadly. Right now, I'm getting my data from Nate Silver and 538, and he makes available all of his polling data, which is really great of him to do so. Real Clear Politics offers an API as well, which I kicked around with in the past, which I've also heard is okay. But realistically, if you're doing this yourself, you have to get the data through an aggregator. There's just no way that you can get the opinion polling data yourself. It's just not going to happen. It's too difficult. So it has to come through an aggregator. Okay, so it's time to do a little software demo. So I'll show you how this works. Right. Okay. Guys, can you see my screen? Can you see a picture of the White House? Yep. Okay, wonderful, thank you. All right, so this is the application. It's called Silkworm for reasons I won't go into. It's entirely written in Python. All right, every single line is in Python. So let's go to the Manage Data tab. I can have a look at the data that's in the system. I have the Electoral College allocations. I have the previous presidential results in the system, though not all of them. In this case, I've just got 2020 data in the system for today's demonstration. I've got 2016 data hanging around and 2012 data as well, which I'll include. But this gives you a sense. You can actually look at different elections, pull the data in, do different sorts of analysis. Run load forecast, right? So I won't run the forecast. I've run it earlier. It just takes about a minute to run because of the amount of data. But I'm going to load what I analyzed previously today. So now I've loaded up the 2020 forecast models, and I can have a look at the vote forecast by time. So this is the money shot. I'll just make this a little bit bigger so you guys can see. So along the x-axis is date, and the y-axis is electoral college votes, and this is the 270 to win line. And as you can see, it's forecasting, my model is unsurprisingly, maybe to most of you tuned in, it's forecasting a large Democratic victory. Okay, so if I just hover over, we'll see what it's saying. Okay, right now the latest model is forecasting 374 electoral college votes for Biden and 164 for Trump. You can see how it's changed over time. Some of these large flips where you get states that are flipping. I think this large one might be Florida, I'm not sure. But you can see some of the other states as the states flip. So you don't get an even model. What happens is in the polling data, as you consider a poll flipping from one candidate to another, you see these discontinuities in the chart. I want to also point out to you that apart from back in March, there was no time where Trump has been in the lead according to this model, right? And you can see a few cases where it's dipped down, but you can also see, something about the direction that this is heading as well. Right, so we can look at the Electoral College vote forecast. So this is the distribution between 0 and 538 Electoral College seats. This is a probability distribution function. And we can see here's the different probabilities, right? So the Democratic candidate and the Republican candidate. We can see that not all probabilities are possible, right? There's some combination of Electoral College seats which are just not possible. But here we can see the way, the way it's working out. We can see that different combinations. You could see that my previous chart showed you an Electoral College forecast, but had things been ever so slightly different, you could see it would jump around between these different peaks, right? And there's not much in it between these peaks, right? But note that there's almost no overlap here, right? My model is clearly favoring Biden, but I have to say in 2016, my model clearly favored Clinton as well. So let's go back and I'll move a slider so we can have a look and see how this probability distribution changed for different days.
So there are a few questions in the chat
Sure.
right now.
Yeah.
First is from Adam on, is that landslide what we're anticipating? I'm assuming the landslide for voting Democratic.
Yes.
From the previous, okay. And then Landon asked, how would you model the election results on November 3rd in the event that the Supreme Court contests mail-in ballots?
Wow. That's really hard. The opinion polls just don't capture that. That would have to be something outside of this model, right? Bearing in mind the questions that people are asked, I think some are asking about how people intend to vote. I haven't seen much. I've seen some of that go on in the opinion polls, but not enough to draw any kind of conclusions. So you'd have to develop some kind of model for what would happen. So that's an election model based on mail-in votes. Difficult to do. Actually, could we hold on to that thought as well? Because I want to talk about electoral fraud at the end, and there's some pieces tying into that. I think because we could talk about electoral fraud and that as well. So Landon, could you come back and ask that question a bit later? Okay.
And then there are a few more questions.
Oh, wow. Okay.
So Joy asked, can you show the 2016 prediction?
I could, but not tonight because I haven't loaded it into the model, unfortunately. So my screenshots were a little bit like this. They were less certain. The results were a lot closer in 2016. I still had Clinton having a convincing victory. I had her winning Pennsylvania, Michigan, and Wisconsin, right? So, and I think there was I think maybe North Carolina as well. So my model was still out. It was still favoring Clinton as well, right? So the question is obviously, is my model wrong again? And it could well be. Bearing in mind, I'm relying on the underlying polling data to be correct, and it was wrong in those states. If, and only if, those pollsters have correctly addressed the education issue, will this model be reliable? If they've got it wrong, right, then this model is going to be wrong as well. All I can tell you is that for 2018, the pollsters, and I'm looking at the same pollster data, for 2018, when they were forecasting the results of the 2018 election, largely the pollsters got it right. And this time they did include education. So there is some recent track record, but always, so, with all of these models, you have to take them with a pinch of salt because there could be a factor that has not been included, right? And the pollsters could get it wrong. And bearing in mind, that's why I was at pains to point out about the UK example as well. The pollsters have got it wrong in previous elections. They've got it wrong in other countries as well. So please don't take this as being certainty. It is a model, and it could well be wrong based on the underlying data.
Kirsten also had a follow-up question on the 2016 prediction. She said, you said 2016 polling stopped weeks before the election. Was your model based on that data, or did you have access to data up until the election?
Okay, no, I just used so I used the data I used for 2016. In fact, okay, let me take a step back. If you go to my GitHub page and you poke around, you'll find the 2016 data. And one of the things that I have to do is make that a little bit more easily available, right? So the 2016 data I got from the Pollster API, those were active then. Nate Silver wasn't so active, at least in terms of making the data available in 2016. I got the latest opinion polling data from the Pollster API, and I got it when it was published. The problem in 2016 is that a lot of the state level polling stopped a week or so before the election. Now, this time, apparently they have promised that they will continue, but bear in mind the pollsters need money, right? People are paying for these opinion polls. So if the organizations that are paying for the opinion polls don't want to pay for a last minute opinion poll, it probably won't happen. Right? So that's one of the issues with this as well, that you know, if you look at where the funding's coming from for opinion polls, it's from newspapers, right? Newspapers and other sources as well. If they decide that they can't be bothered with it or the election's a done deal, they won't pay for a last minute polling. So that is still a vulnerability in this model as well. I think one of the ways of capturing whether there's a last minute swing is to look at the national polling results, which is not in this model at all. And some models have a correction at the state level for national pieces, and you could probably attempt some correction for a last minute swing based on national data, but I don't do it in this model.
And John had a question also on, in the UK opinion polling tables, they give you breakouts, demographic breakouts specifically, like by age, gender, education, location. Did you have these breakouts available in 2016 in the US, or is it a case of it being available but trapped in a PDF prison like in the UK polls? Wow,
John, you are dead right. Yes, it is trapped in a PDF prison. You can get the data out. In fact, I'll take a little digression to tell you a story, right? So the kind of data that John is talking about is cross-tabulation data, and it's data that, again, you can see the demographic breakdown for what they actually measured, right? The idea is that according to the American Association of Public Opinion Research, AA, and sorry, the acronym is awful, but anyway, according to their rules, that pollsters must keep that data and they must make it available. And a lot of pollsters do, but some do not. A lot of the data that's polling data that's made available is in PDFs, which is why I talked about having an aggregator to pull that data out, right? The aggregators don't pull out the cross-tabulation data. Polling fraud has been committed, and it has been committed by companies, and they've been caught out because they haven't made the cross-tabulation data available, or when they have made the cross-tabulation data available, it's clearly indicated fraud. Okay, and on my blog, I actually talk about a couple of cases where fraud was found through that data. But yeah, John, you're right. It's just really difficult to get that data, and the aggregators don't pull it out. And in effect, it's impossible for a hobbyist like me to pull that out. The level of effort is just too great. So a few more questions. Okay, let's go. Generated a lot of interest. So one of the question was, are you able to generate a 95% prediction interval as an example, or just point estimates? Yes. So I am, and you will see that when I go to the other tabs in this application. I was going to put a 95% confidence interval on this chart, right? But then when I looked at this distribution, I realized I'd have to give a bit of a think about what that meant, right? And how I would actually work out what the 95% confidence interval was, right? So it's not as straightforward as it appears to be. So yes, you could do that. You've got the data to do it. In fact, to put the 95% confidence interval on, you'd have to use this data. All right, just not quite exactly sure I haven't given it enough thought to how to use it, bearing in mind the nature. And there's some, let's go and find a recent place where it gets a bit crazy. Okay, something like this. I mean, some days, some of the results are a little bit hard to figure out what the 95% confidence interval would look like. But in principle, it's possible to do it. And in some of the other charts that I'll show you a bit later, I have done it.
On a related note, Eric mentioned that 370 would imply Biden wins in Ohio and Georgia or Texas. That scenario is a little in front of 538 and Gelman and others in The Economist.
Yeah.
How do you quantify confidence in your prediction?
Right. So those are good questions, right? There's a couple of things. I use a shorter time window, right? I use a 7-day window. One of the problems with that window is it's subject to fluctuations, which we'll see in when I'll show you a couple of tabs. You can see that some of the results, in fact, if you remind me of those two states, when I show you at the state level results, we can have a closer look at them. When you look at it, my model is more susceptible to flipping because of that. And the reason why I've shortened the time window is because I wanted to capture last minute changes in voter behavior. The problem with doing that is your model is more susceptible to changes as well, right? So yes, at the state level models, I will show you, and I will show you the 95% confidence intervals for those models as well.
Great, that was all the questions so far.
Okay, all right, we'll come back to that. Please don't, if I don't answer the questions later with what's coming up in some of the tabs, let me know. All right, so I've showed you the distribution on a daily basis. Let's have a forecast by geography, which I think has just been asked. So you can see the states. Actually, I'll go back to the beginning, right? So the data set starts in January 2020. Now, what happens in January 2020 is that the data is dominated by the previous election results. And as more polls come in, right, as more polls come in, you can see the results settling down a little bit. Right, I'll just move this along. Right. So you can see here's Ohio. I actually have Ohio as a dead heat, right? So it might, the way that it might work out in my model is it might flip to Biden. I'm not entirely sure how it copes with dead heats actually, because it doesn't occur that often. I forget, what was the other state that he mentioned? Oh, Georgia. Yeah, I have Georgia going for Biden by about a percentage point. But again, it's probably because my time window is shorter than the other models. The other thing that I don't do is I don't do smoothing. Now, I know that both The Economist and 538 do smoothing as well. I've got a very abrupt transition. So The Economist in particular, when it's working out its the path between points, it uses a smoothing algorithm, which I don't use. So my model is much more susceptible to swings here. And I've done that deliberately because of what happened in 2016, is because I'm trying to capture those kind of swings in voter behavior. The problem is that it will give my model more variability than the other models. As a question of who's right, I don't actually know how you could do that other than the final forecast, right? Because right now, no election has been held. And if my model is different from The Economist's, is different from Nate Silver's, it's a question of who's right. Right, so we can't really tell right now. All we can tell is at the end of the process where we end up. And my suspicion is that we might actually end up all in the same place. Right, so whose model was right during the election campaign, I don't know. And I'm not entirely sure how you would work that out, frankly, to be honest. We can have a look at the election models by state. Right, so this is where the 95% confidence intervals comes in. And I think we asked about Georgia. Hopefully I remember that correctly. Right, so this is a bit of a mess. So let me clean it up. Let me turn off the 95% confidence intervals and turn off the polls. So here we have the Democratic and the Republican votes as well. So if I turn on the opinion polls that we've got, so you can see how my algorithm is basically doing its aggregation of the polls. If you have a slightly different aggregated model, you'd end up with a slightly different result. If I hover over the polls, it will actually tell you who the polls are, the Democratic and the Republican percentages and whatever. But note, there's tons of outliers. And this is just one of the features of opinion polling when you've got lots of polls, loads of outliers. So if I put on the 95% confidence intervals, you can see that basically, although there's about a percentage point difference between the candidates and I have Biden leading in Georgia, frankly, it's within the 95% confidence interval. Right, so I wouldn't call that a certain result by any means. right? So my model is a little bit more responsive than other people's. I think with a little bit more smoothing, maybe it would be, it would go either way. But there's a lot of states that are really close right now. Okay, so that all it would take is one or two polls to flip them, and that's what you see in my model as you see the discontinuities. And
So,
okay.
So John commented that smoothing feels like it should just be a user toggle able preference. As you say, it doesn't really matter. Or could you use an A/B test, smoothed versus a not smoothed, and see which generates more page views?
Yeah, I suppose you could. So I've just chosen, I've used pandas for this, and I've used, just straight out linear interpolation. The reason is I wasn't sure what's the best model of if you were to, in effect, you're not making this smooth. What you're trying to do is model what's going on out there. And it's not clear to me that a smooth model is preferable to a more linear model. So I don't know. So I could actually, if I was trying to get clicks for this, I could maybe put this on a website and have maybe something where you could choose different smoothing algorithms. And actually, that's not a bad idea. Actually, I could change the smoothing algorithm so you could have a look at how it affects the results. Right, not crazy. And in fact, I like the idea of doing an A/B test. I could have maybe this is a website where you click away and see whether people prefer a smooth view or my very harsh linear view. So I was a physicist, and I know that this kind of harsh linear view is not representative of the physical world. But then I'm not sure whether a smoother approach is actually more accurate. I seriously need to do some research work about that, and I'm not sure a lot has been published.
There are two questions about the types of data you use, or data. First is from Sebastian about, do you ever use Senate race polls to predict the general presidential election? For example, the South Carolina race is pretty close this year. Yeah. Would that impact your forecast for the presidential race?
No, but so actually you raised some very good points there. So I only use state level opinion poll data. I don't use anything else. Senate races, I don't know. So I've tried to stay within the science here, right? And I don't know what that says about, adding in a state level for a Senate race or a House of Representative race, whether to add that data in or not. I don't know if that would help. I'd have to play around with it and see. I'd also have to have a look to see what was in the literature about using those other data sources as a predictor. However, there is a more general point. Both Nate Silver's model and the Economist's model, another big difference between my model as well, is that they use national results to modify the state level results. So for example, let me choose a state where I don't think there have been any opinion polls. Okay, Wyoming, okay, there have been. There are a couple of states where there haven't been, maybe Montana there hasn't been. Oh, good grief. Okay, so anyway, let's just take Wyoming, right? So there've only been 4 opinion polls in Wyoming. Right, let's imagine that there was only one and it was an outlier. Right, obviously you would get a skewed result. The idea here is that you take national opinion poll results and you modify the state results by the national results. So let's say that I didn't have any opinion polls for Wyoming. The idea is that I would modify the voter data, the 2016 data, by the national results to get what I believe is a sense of what's going on based on national data. So the idea here is that in Wyoming and maybe Alaska and Hawaii and whatever other states that don't have many opinion polls, that you can model the changes in behavior in those states in the absence of opinion polls by the national data. And that's something that Nate Silver does. So if you go in and you have a look at his opinion polls and you have a look at some of the states that don't have many opinion polls like Wyoming, you'll see that he has much more variability in his model. And that comes from including the national data. I don't know whether to include that or not, and what I'm in two minds about. So one is it's obviously it's a data set that has relevance, right? It is asking about the election, but then do voters in Wyoming or Montana or Massachusetts or any other state, would you expect them to follow the national trend? And that's not clear to me that you would, right? So I'm in two minds whether to include it or not. Most other modelers have. And that's another one of the reasons why it could well be between my models, Nate Silver's model and mine, it could well be that maybe he's seeing a slight national difference, which is moderating some of those results in favor of one candidate or another. And I don't have that moderating factor.
Here's the other question. There is actually an internal conversation going on while you're speaking. The other question was, have we considered typical election day stuff like weather? So for example, a giant modern northern storm thundering through the Midwest from Minnesota to Philadelphia could dump turnout. And in this internal conversation, there was actually articles posted where UK Parliament looked into the effect of weather and daylight hours on elections, and it doesn't seem like there was basically no correlation between the weather and turnout, according to Stephen Fisher, who's an associate professor at Oxford.
Okay, yeah, I've heard that. I don't know, there are other factors, election day factors. You know, the idea is that maybe in the UK, Conservatives benefit from better weather. I've heard all kinds of craziness as well. I've not really seen the data to support or deny that. So this is based on opinion poll data, and you know, it obviously does not factor into weather pieces as well. A true election model might include things like weather and a few other bits and pieces as well, and maybe even the availability of polling stations, frankly. But those, yes, it might be worth doing. I would definitely have a look at the data before you include it, though.
I think the last comment comes from Eric about how Gelman uses state to inform state to. The idea that Michigan, Wisconsin, I think, and Pennsylvania might swing together. He calls this out as a big delta between his model and 538s. And cities that as a reason for, or sites that as a reason for greater tails in the 538 scenarios.
Yeah, so that's an interesting piece. That's a really interesting. Right, so when I showed you the generator polynomial, right, a while back, and what that's suggesting is that all of the states are independent. But there's a question, are they really? And the idea that, you know, these guys have is that groups of states are influenced by one another and don't necessarily act independently of one another. So you may well have states, you know, a group of very conservative states or a group of very liberal states, and they're influenced by one another, and they tend to vote in the same way. So it's a coupling effect that's going on. I've heard about this. I don't know. I think it's a difficult thing to model. The problem with modeling this kind of stuff is that you don't have a very big data set. You've got elections, presidential elections every 4 years, and things change. So your data's quite sparse to draw any conclusions. It wouldn't surprise me if there's some kind of coupling going on. I don't include it in my model, but I've heard of it, yeah.
There's another question from John is, are you able to backtest how well this model design would have performed by simulating its forecasts on historical elections?
Yes, so I'm able to do that, to go back to 2016 and 2012 data. For this particular iteration of the model, I haven't done it because I ran out of time to do it. The other reason for having some issues with going back in time is the data set. And I'm going to summarize in a little while and tell you some of the things that I have to do. The problem is that my polling data for 2020 is in a different format from 2016. Right, the 2012 data and the 2016 data I've got comes from the Pollster API, which is data in a certain format, and then Nate Silver's is in a different format. And even things like that munging of the data to get it all to work together involves quite a lot of effort, frankly. It is possible to go back to earlier elections, 2008, and even back into the early 1990s, if you are an academic and you have access to certain academic libraries of election results. So the Roper Center, for example, has a library of polling going back, 50 plus years, but you have to be an accredited academic to get hold of that data set. And I'm not, I'm just some guy off the streets. Okay, any other questions?
No, I think that was it so far.
Okay, so I'll go to the last tab here, which is the poll viewer, right? So you can actually view the underlying opinion polls for that state. So here's the Ohio polls, and what you can do, if there's a lot of them, which there are here, you can narrow the range, shift things around a little bit. We can look at another state. Well, let's look at Georgia. And there we go. You can see the polls for Georgia and the other states as well. All right, so that's Silkworm. Let's go back into presentation mode. Okay, I want to talk about the software architecture for this. So for those of you who are interested in building business intelligence apps based on Python, this is the piece of the talk that will interest you. It's 100% browser-based user interface, 100% object-oriented Python. It uses a model view controller architecture, or actually rather a variation of that. It's entirely, if you were to build a business intelligence app using Python, this is the approach that you would take, and it would look very much like it. And I'll tell you how I know that in a second. The library, the visualization library, is Bokeh. The libraries generally used are Bokeh, Pandas, NumPy, SciPy, and a few others, basically all the usual suspects. So if you're going to build an application like this from scratch and use the model view controller architecture, that follows a pattern. And if you're going to use Bokeh widgets to implement stuff with drop-down boxes and menus and buttons and charts and all those things, they all follow a pattern as well. And there are callbacks in there as well. So given the fact that the callback functions and the widgets follow a pattern and model view controller follows a pattern, can't you just automatically generate this stuff, right? If it all follows the same pattern, why can't you just generate it automatically? You can, right? So I have written for my employer, I've written a tool which will, you start with a JSON file, and from which the JSON file is on the right-hand side for this project. And from it, you can automatically generate an application with widgets, and it will actually run and show you the widgets. So you get a sense of, okay, it's not connected to the data source, but you can see the relative position of the widgets to one another, and you get a sense of whether you've got the right widgets and the right controls or not. So it generates the model view controller framework, all of the tabs that you saw, all of the widgets. The code is PEP 8 compliant completely. It's runnable. Unfortunately, it doesn't fully lay out the GUI. I'm working on some ideas to get that done. And there's no automated way of dragging and dropping components onto a canvas to generate code. But the point with this automatic code generation piece is that you can focus on the value add and not the tedious work of wiring up the components. Right, so in the future, what I intend to do is to complete the widget coverage in Bokeh for automatic code generation. I also intend to do something about including layout, so I can automate the layout a little bit if possible. Auto-generate Sphinx documentation, right? I can do that. I can lay the stubs for that and auto-generate the project. I just haven't done it. And what I would like to do is to get to a state where you can have a Visual Basic-like interface where you can drag and drop components onto a canvas and auto-generate the whole application from that. That's what I'm working towards. It's going to take a long time to get there, but I think I can see what the result would be. So some commentary on this, all right? I'm going to talk about my experience of using Python to generate business intelligence-like applications. So this thing that I've showed you today is a hobby, right? It's something that about every 4 years, I kind of wake up and I do some playing around with. My day job is a senior director. I have teams of people report to me, and I've taken advantage of that to have the teams build business intelligence apps using Python. And the reason for doing it is, the data scientists know Python, they don't know Tableau, and they don't know some of these other tools like Click, for example. So I'm taking advantage of the existing skill set that I have available to me to go and build applications used by the more general business. So in terms of functionality, it compares very well to Tableau and Click. Security definitely is a non-issue. Scalability works very well as well. So it definitely competes with those business intelligence apps using this approach. But there are knowledge barriers to entry here. So a lot of data scientists aren't familiar with callbacks and UI programming. And again, although I've tried to automate that away, I haven't quite got there yet. So realistically, to do this, you have to train your data scientists a little bit in how to use callbacks. Ginger 2, which is a templating piece. A lot of data scientists know it, some don't. But then we're going to use a lot more of this in the future. But still, given all these factors, it is still very labor intensive compared to using Tableau and Click to build an application like the Silkworm application that I've showed you. Probably a factor of 2 or 3 times longer, frankly. The manual layout is very difficult. It's quite difficult to do. And things like data table, data sliders, and file inputs, those are very effort intensive widgets to get right. And in my code generation, I've tried to flesh them out. I've still got a ways more to go with this as well. But the whole goal is to reduce the cost of building Python-based business intelligence apps using the approach that I've told you. Speed of development, I'm hoping to get that down from a factor of 2 or 3 slower to something that's maybe 1.5 to twice as slow, right? But again, If I had Tableau developers and Click developers, I would use them, but I don't. I only have one. But I do have everybody on the team knows Python. So it's easier to use that skill set to generate this kind of application. All right, so some lessons learned and what's next. So what's next? So the US presidential election for the Silk Road project, the error model I need to get right. I haven't taken into account these systemic biases. I need a good way, frankly, of including them in the model. Nobody's asked about Bayesian. I have a very basic version of Bayesian in the model. In the previous version, I had something more sophisticated. I think I probably need a more sophisticated Bayesian model. I suspect that Nate Silver has one, which is why his model is different from mine, why I think it's a bit smoother as well. And he doesn't have the violent variations that I do. I think I need to put in a better Bayesian model. Maine and Nebraska. Now, Nate Silver definitely treats Maine and Nebraska with a congressional district method. I don't. I need to include those as well. And there are enough polls in the different congressional districts for Maine and Nebraska to produce a result. The poll filtering, well, just doing this manually is awful, and I've done it in Python code. I really should do it in schema to take it out of the code, adjacent schema or something. I've just got to figure out a better way of doing it. I also need to normalize all of this data, all of the 2012 data, the 2016 data, and the 2020 data, and put it into some SQL database. It's not normalized at the moment, which makes looking at multiple elections a bit difficult. Beyond this, a US election forecasting, looking at the Senate and the House, this approach would work. Because there's no electoral college for those places, it's actually simpler. I could use this model, well, okay. It would be difficult to use this approach in countries with multi-party democracies like the UK or Ireland or Germany. It is a much, much harder problem. It's orders of magnitude more difficult, right? And I could talk about why that's harder. The US is almost a perfect country to do this kind of modeling because you've got two parties and plenty of money for enough opinion polls, and you've only got 51 states, including Washington, D.C., to model, right? So it's a lot simpler to model than other countries. And electoral fraud. If anybody asks, we can talk a lot more about electoral fraud. I've got quite a bit to say about that. But before I just say, largely it's non-existent, right? But there have been organized efforts, for example, in North Carolina. I think I have found ways of, I think there are ways of detecting electoral fraud, which we can talk about later. Right, so some lessons learned here. Polling is hard. So I've worked in a lot of organizations where they want to do opinion polls, either opinion polls of their customer base or HR wants to poll employees. And I feel like getting up off my table and giving people a good slap when they say it, right? Because I don't think there's any appreciation of just how difficult this is. And it's usually the people who are most enthusiastic about running polls are the people with the least experience. Right? So polling is hard. Also, some more general lessons here. Generally, you need to understand how data is collected. I was very fortunate that I had an experience as a market research street interviewer. I knew that basically random sampling does not exist. But if I hadn't had that experience, I would be tempted to take the textbook approach, which would be wrong. So I just urge everybody, maybe the more junior people on the call here, that when you're analyzing a very large data set, understand, especially internet data, understand how that data was collected. Secondly, you can't fix fundamentals. So the 2016 data was fundamentally broken because it didn't take into account education. There is no way of going back and retroactively fixing that data, and no way during the 2016 election you could have detected it. Well, you might have been able to detect it, but you certainly couldn't fix it, right? And in fact, the Literary Digest example is a classic case of how basically size alone isn't enough, and if you have the wrong methodology, no matter what the size of your sample, it's going to give you the wrong result. The other piece takeaway that with a few honorable exceptions, the statistics books and courses are wrong. They talk about random sampling and they talk about other ways of combining polls, which don't work in practice, okay? Now, I'm going to finish up by giving a quote from George Box, a famous statistician. And it's really about humility, right? Now, I'm presenting these results. I am fully aware that they might be wrong. I had the experience of giving a similar talk 4 years ago, where I stood up and I very confidently predicted a Hillary Clinton victory, right? So that's taught me a little bit of humility as well. The model is what the model is, and it is susceptible to problems, and it makes its predictions. All of these models are me, Nate Silver, Sam Wang, The Economist, everybody is subject to error. And that's the same for every data scientist. If you're producing a model, you are subject to error and you might well get it wrong. So there's a little bit of humility that I learned 4 years ago, which hopefully I've continued forward with. So let me end with a quote from George Box. All models are wrong, some are useful. Okay, so we'll move into some more general questions here. For those of you who want to link to me, I put it in the chat. Maybe it's been lost because I hear the chat's quite active. Here's some image credits. They're all from open source sources, and I have to acknowledge them to stay compliant with the licensing. And there we go. So I will take some questions.
One came in about why is it easier to predict popular vote outcome? Does it change the approach?
No. So the reason is that if you're looking at a large scale, you're looking across the US, there's lots and lots of national popular vote surveys. So it's just the volume of opinion polls is greater. So for example, you might have a national opinion survey that's run every 2 or 3 days, whereas even in a state like Florida, there might be a week between opinion polls. Right, so it's the frequency of the data. In fact, I did do an opinion poll post where I talked about what was wrong in 2016, and I did actually download the national opinion poll data for 2016 to play with it. I could see that the number of data points was really quite large, right? And it's very frequently surveys as well. So it's actually, you've got a much richer data set to play with, so you can make better forecasts using it.
Yeah, we might have to have a countdown. You know that, or there are no questions, right?
Right, so guys, maybe I've just stunned everybody by yapping away, but if you have questions, what am I, right, okay. So
so let's put out the question first.
Yeah, okay.
Eric asked, what are users doing with the business intelligence apps your team delivers? What kinds of judgments are they making?
Okay, I am going to have to fall back on company confidentiality here, right? So it's an internal app. What I will say about the app is it presents a view of the internal data. So it's a large data set, orders of magnitude bigger than the data set that we're talking about here today. It presents summary views of the data to enable diagnosis at the account level and other levels of problems and of trends in the data set as well. So it's very much a chart-based view of the data. There's different plots that you can look at, categorical data, time-based data, other bits and pieces as well. So it's a chart-based, the systems are chart-based. There's a couple of drop-down boxes and data tables and other bits and pieces in there as well. But all of them are to do with data and data quality and looking at results and trends of data as well. So if you like, it's an active, very typical business intelligence data piece. I can't be more specific than tell you that it's to do with finding problems in the data and finding trends in the data. That's as specific as I can be, I'm afraid.
John asked, do you have any plans to open source your business intelligence app generator? Or if that's not currently possible, would you like to make it happen?
So I would like to make this happen. I have had a chat with my employer about this. So we might actually do this. I don't know if there's anybody interested in this as a project taking it forward. I think it's something that if multiple people worked on it, it could make a difference, right? We could actually make some progress. Got a little bit of cleanup to do on this, as I think I implied. I've got a bit of cleanup to do with it. There's some things that are not quite right. But once those things are done, it will actually work pretty well. In fact, it works well, it just doesn't work well enough. I think what I would like to do, in an ideal world, I would like to open source this. I would like to get a group of people together to work on this. And what I would like to get is, my vision is to have something like Visual Basic. You know, we had, 20 years ago, we could drag and drop things onto a canvas. I'd very much love to get to that. And I'd love to get the code generated behind the scenes to do that, and then leave us with basically wiring up the business logic. I can see that all the technology exists to do it. There's nobody actually doing it.
There's another question on, are your users working with point estimates or measures, or do intervals come into play for them?
I guess this is to do with my work applications. So let me talk. So a lot of this is charting trends over time and different views over different kind of time periods. There are some uncertainties in the measurements, so we do have 95% confidence intervals. Some of the other things that we do is we look at whether data follows the distribution types it should. So for certain types of data, it should follow certain distributions, and I can't be any more specific than that, I'm afraid. You can look for deviations from that. And some of the work that we're doing is actually looking for statistically significant deviations from that data set. So I'm not entirely sure if I've answered your question, Eric, but I can't really be that more specific, I'm afraid. It's all confidential and proprietary and stuff.
I think I'm going to start a countdown. Oh, no. Oh, well, Eric, thanks you for your response. Oh, he also wondered about the presence of stats in business intelligence apps.
Okay, so I'm going to have to come a little bit clean about my background. I used to work for a business intelligence company, right? It's what they tend to have is a fairly limited library of analysis functionality, right? All of these tools, right? No one has the kind of strength and depth that R and Python have, right, in these proprietary models, with the exception of the MathWorks, right, which is a different kettle of fish altogether. So I think if you really want detailed statistics in these models, you've got two choices, right? So one is that you auto-generate the data beforehand and you put it into database tables and you use Tableau and click to query the results, and you offer the user options from a limited set of options, or you enable some full-on statistical analysis in which you'd have to go to BI tools built with Python or R, for example. So if you really want that firepower, if you want a user interface that has that statistical firepower, in my view, you have to go to these applications. And that's one of the reasons why I'm playing around with this data set in the way that I've done it to figure out what I can do. So this is a hobby, as I've said, but it's kind of bleeding over into the business world as well. And my sense is that I want to be able to produce business intelligence apps using Python a lot faster so I can use the resources on the team better, and to use some of the statistical firepower and the general purpose programming structures that are available in Python.
Great. Going once.
Okay, everyone. Just a final comment here. If you want to link on LinkedIn, I'm open. I'd like to see this conversation. I talked about this. I will blog out this some more. If you want detail about this, you asked about electoral fraud. I was kind of laying this out. I've got some, hopefully interesting things to say about electoral fraud. Again, I don't think it's something that's a reality, right? Not in the way that it's being painted. There are certainly no armies of people committing fraud in the United States. There's just no evidence for it. I can tell you where you can go and find data about electoral fraud if you're interested. So, but nobody is, unless you want to ask in the dying seconds. That's it. But I'm open to link on LinkedIn, and if you want to talk or you're interested in hearing more, I could go and post a few more blog posts and describe things in more detail if you want.
Yeah, thank you so much, Mike, for coming and speaking with us today and having a very timely topic given the upcoming elections. And I want to thank everyone for having this hearty conversation and having a real Q&A in the middle of the talk, at the end, and sticking through with us. We hope to see you at our next event. And yeah, don't forget about PyData Global. Someone actually joked about having your project as a PyData Global sprint.
With a BI stuff, if I could get a company to agree, I would be open to that.
Great. Thank you, everyone.
Good night, everyone. Thank you.